Right. The question of interest is question 7, as we have seen. The paper being Cambridge International Examinations, code 9709/62, taken in February-March 2018, Probability and Statistics 1, paper 6. Question 7 reads, yes, it reads, the weights of packets. The weights of packets of a certain type of biscuit are normally distributed with mean 400 grams and standard deviation 30 grams. In a random sample of 600 packets of this type of biscuit, 225 packets weighed more than 410 grams. Find the value of the standard deviation. That's 4 marks. Roman 2. In a random sample of 500 packets of this type of biscuit, how many packets would you expect to find with weights that are more than 1.5 standard deviations from the mean? That's 4 marks. So that's the question of interest, and we dive into the solution. Well, we proceed as follows. We are told that the weights of those packets are normally distributed with the mean to be 400 grams, and standard deviation is not given, and a random sample of 6,000, that is N is 6,000 packets, was taken and weighed more than 410 grams. Find the value of the standard deviation. So we are told that in a random sample of 6,000 packets of this type of biscuit, 225 packets weighed more than 410 grams. So that can give us an idea of the probability, because now if we say 225 divided by 6,000, that gives us the proportion that weighed more than 410 grams, and that proportion is 0.0375. 0.0375. You can confirm using your calculator. Then, so in this sense, what we are saying, okay, if in a random sample of 6,000 packets of this type of biscuit, 225 packets weighed more than 410 grams. So probability that Z is greater than 410 minus 400, which is our mean, divided by the standard deviation, which we don't know, is giving us this. It's giving us 0.0375. 0.0375. So in effect, we can then find the Z value that corresponds to this in our table. So we'll locate this in the body of our standard normal table, of our normal distribution table, and then cross-check the corresponding Z value and equate to this in order to get this. Now, that Z value is now for Roman 1, we find that 225 divided by 6,000 is 0.0375. And for us to determine that probability from our standard normal table, we subtract it from 1, and that should give us 0.9625. So 1 minus 0.0375 is 0.9625. That's a probability. We check it within the body of the table. So 0.9625, it's here. Yes. And it corresponds to a Z value or a Z reading of 1.78. And so that is our Z value that we use to work out the standard deviation. The Z value is 1.78. The Z value is plus or minus 1.78. So if we subtract this from this, we get 10. So that should imply that 10 all over that should give me 1.78. Therefore, the standard deviation is 10 divided by 1.78, which gives us 5.62. 5.62 as the standard deviation. This you can still say is that should imply that standard deviation is now 10 divided by 1.78, which gives us this. So that's the standard deviation. So that's Roman 1. Roman 2, we have, the question is, in a random sample of 500 packets of this type of biscuit, how many packets would you expect to find with weights that are more than 1.5 standard deviations from the mean? Weights which are more than 1.5 standard deviations from the mean. Let's take a case. If this is the mean, let's say it's 400, then it's possible to have, and this is 3 standard deviations. Let me say this is 3 standard deviations. This is 3 standard deviations. Yes. So if we are expecting a division of 1.5 standard deviations from the mean, we are going to expect it this direction or these directions. Ones which are less than this by that 1.5 will be this end, and ones which are more than will be that end. So in effect, what we are looking for is the probability that Z is less than negative 1.5. That will represent from this end to that end. And probability, the term and here is used to imply mathematical probability aspect. So P will be probability of Z greater than 1.5 because it is also more than 1.5 deviations if it's greater that other end. So those are the 2 probabilities that we want. And we see that this can be written as 1 minus phi of 1.5. And this will be written as 1 minus, because of the, 1.5. You see, for us to get that probability, that other end, we'll have to subtract that probability from 1 so that we get that value of Z. So that's what we have. And if we add this, because it is this probability and that probability, we are not multiplying, but now OR, we are talking about OR. So we'll be adding those probabilities, and what we get is 1 minus phi of 1.5 plus 1 minus phi of 1.5. Phi of 1.5 should be 1 plus 1, that gives me 2, minus 1.5 phi minus 1.5 phi will be 2 into 1.5. 2 into will be 2 into phi of 1.5 into phi of 1.5. Phi of 1.5. So what we do up to that is 2 minus 2 phi of 1.5. Now, now having that, we are then supposed to read the value of, this probability. So this is the value of Z. So we check under the Z column, which value, under the Z column, we go up to 1.5, then read the corresponding probability. That probability is this. Now here we want the Z value that corresponds to, no, we want the probability that corresponds to a Z reading of 1.5. So Z reading of 1.5, we find it here to be 0.9332, and that's what we take and write in our equation. Yeah, and we see that it is indeed now 2. That probability we see it is 0.9332 as we have read from the table. So if we substitute that here, it will be 2 minus 2 times 0.9332. That should give us, if we work out that, it should give us about 0.134. About 0.134. That's the probability. That's the probability that we sought to find in Roman 2. But that was not all. We are asked to find, we are asked how many packets would you expect? How many packets? So we need to multiply this by 500 because there were 500 in number. So we'll have 0.134 times 500 should give us, if you multiply those two values, you should get about, you get 66.8. 66.8. So you can choose 67. You can choose 67. So that's the answer. That's the number of packets that are required according to that particular question. So that marks the end of it. Please subscribe by hitting the lower button. You can like if you are impressed, and you can also comment, and then we'll interact. Thank you, and see you in my next video. Part one of this question looks like this, because we are told that the mean of these biscuits have actually it's normally the weights of these packets are normally distributed with a mean of 400 and a standard deviation of 5.62. So if we define that, if we put that as such, then we find the probability that Roman 1 requires us to find the probability, to find actually, having already found the value of, the standard deviation, then we can then specify the probability that was required. We want to test if indeed what was given as 0.0375, representing the fact that 225 out of 6,000 were more than 410. So we want to see if we see that if we define probabilities as 410, it's greater than 410 up to 500. I'm putting 500 as the upper limit because we see that in this graph, by around 418, by 420, the probability has already stabilized. So 500 is way outside the range and is reliable for our approximation. So we take it that x takes the value of 410 or greater than 410, and it's less than 500 or equal to 500. That gives us the probability of 0.0376, and it confirms what we get as 225 over 6,000. And that area is represented by this portion of the curve. So if one was to ask the probability that it is less than 10, then it would be represented by the unshaded region. Now that wraps up my presentation for now. We meet in the next video.